When we're doing the network portion of an IP address, we define that network portion with the subnet mask. When we start looking at access control lists and OSPF network IDs, we use something called the wildcard mask instead to identify the network portion or the interesting portion of an IP address. A subnet mask in the notation of 255.255.255.0 indicates that the 255 is all ones. 1111, 1111, 1111, 1111. There's the second 255, 1111, 1111. There's the third 255, and then 0000, 0000. This, again, is the format of our subnet mask. In access control lists, we use what's called a wildcard mask, or also called an inverted mask. And what that means is that all the zeros are interesting and all the ones are not. So if I were to have a subnet mask of 255, 255, 255, 0, and I wanted to use it in wildcard mask notation, wherever there's a 1, I make it a 0. Wherever there's a 1, I make it a 0. Wherever there's a 1, I make it a 0. Wherever there's a 0, I make it a 1. Oops, there was an extra 1 there. So if I convert this back to decimal, 0.0.0.255. And that's effectively how the inverted or wildcard mask works. So would I expect you to do out the binary and convert the zeros to the ones of a subnet mask? No, there's got to be an easier way to do it, and there's absolutely an easier way to do it. If we think back to subnetting, one of the formulas that we've used in the past is that we have 256 minus funky is block size. Whether you've used that one or not before, you don't need to know that one specifically to get the next one, which is 255 minus funky is wildcard. So if I do 255.255.255.240, and I want to know what the wildcard mask is for 255.255.255.240. Again, what I end up doing is taking, well, I know that all the 255s are zeros, so now I just need to know what 240 is. So 255 minus 240 is 15? 15. Does that make sense? 1111111, 1111111, 1111111, and then 240 is 111100000, and I'm not going to convert all of these. We know how this converts to 0.0.0. The only one I'm interested is this conversion. Every 1 becomes a 0. Every 0 becomes a 1. That's 8 plus 4 plus 2 plus 1, 15, 15. So our formula actually works for us. It doesn't really make a difference where that is. I'll put that formula back up there. Got a little overzealous with my erasing, I guess. So 255 minus funky is block size. If any of you have happened to miss it before, what's funky? So when we look at subnet mask values, 0 and 255 are not funky. These are not funky. The funky values are 128, 192, 224, 240, 248, 252, and 254. And these are the only values that you can have between 0 and 255, and these are the only values that you can have in a subnet mask. These are the funky ones. 0 through 255 are the not funky ones. So for any subnet mask I have, I subtract the funky octet from 255. Oof. I wrote that incorrectly. For those of you following on, taking your notes, pull out your eraser. 255 minus funky is wildcard. Okay? One other way that you could look at this is if you happen to know what the block size is, it's block size minus 1. So if I have a subnet mask of 255, 255.255.224, and you can tell me that the block size is 32, then wildcard is going to be 31. One more example, 192.168.10.32/27. /27 is a block size of 32. So the wildcard mask is erase that. The wildcard mask is 0.0.0.31. Just in case you need to know, if you've got a subnet mask that's funky in a different octet. For example, we'll do one more example for you. If I look at an address of 192.168.16.80/22, what is that subnet mask? Well, what is 22? 22 is going to be a block size of 4 in the third octet. 22 is 255.255.252.0. So this is my block size 4 in the third octet. So what is my wildcard mask? It's 0.0. Block size of 4 minus 1, 3, and then 255 in the fourth octet. And that is wildcard masking.